The next book is Feller's Introduction to Probability Theory and its Applications, and this time it's volume 2. We did volume 1 already. And while volume 1 is mostly about discrete probability distributions, this is more about continuous ones. So it covered exponential uniform distributions and other distributions, other density functions, many different density functions. It even goes into probability measures and probability distribution in higher dimensional spaces. It has stochastic processes, the law of large numbers, basic limit theorems, infinitely divisible distributions, semigroups. It goes into renewal theory. It goes into random walks, Tauberian theorems, characteristic functions, central limit theorem, and then Fourier and harmonic analysis. So this is all about continuous distributions, but it doesn't really use that much measure theory. The book is very theoretical, very mathematical, but not too abstract. So it really covers how to think of the subject and how the subjects can be applied within math. So there is some measure in the book, but it's not gigantic. I think this is really a very good book, a very nice book to read through, even though it would not be for everybody. Some people will really like the book, other people will really not like the book. I personally like it, but it would not be your first book on the topic. Next comes the book I really like. It's Priest's Introduction to Non-Classical Logic. Priest is really a big name in logic and in non-classical logic. He does, for example, what's called paraconsistent logic, which is logics trying to reason with contradictions. So it deals with all kinds of non-classical logics. It starts, of course, with classical logics, modal logic. It does normal and non-normal modal logics. It does conditional logics, intuitionist logics, many-valued logics. It has logic with gaps, gluts, and worlds, relevant logics, fuzzy logics, and many-valued modal logics. And then, of course, it also introduces quantifiers into these logics. I like this book a lot. It is a very nice overview of very different logics and very different themes of thinking. As you can see, it does all of these with what's called tableaus or truth trees, which is a very nice touch, even though it's not one I personally like the most. As you can see, you really want to have some kind of knowledge of logic already and how logic interrelates with each other. So if something like a truth tree or the sounding completeness theorem is not something you're used to, then I would probably not recommend this book yet. On the other hand, if you are used to different kinds of ways of proving things like tableaus, truth trees, soundness, completeness, and all kind of logical reasoning, and you're interested in non-classical logic, this really is the book you want. I love this book. It's a really good book, but make sure you have the prerequisites for it. Then we come to a book on quantum theory. Here we see Isham's lectures on quantum theory. So what does this book cover? It covers vector spaces in the beginning, linear operators, classical physics properties, formalism of quantum mechanics, technical developments, unitary operators in quantum theory. It has conceptual issues of quantum theory, properties of quantum physics, and then some problems. This book is really how to think of quantum mechanics conceptually. The book involves a lot of math, mostly linear algebra and associated math, but it really is about problems and concepts in quantum theory. For example, the measurement problem is dealt with. There are other things of conceptual difficulty in quantum mechanics. The book is not a physics book. It's also not really a math book. It's really a book between the two. It's about the mathematical formalism of quantum mechanics. Next we have Carter, Classical and Statistical Thermodynamics by Ashley Carter. And it's a book on thermodynamics, and it covers the usual thermodynamics properties. Of course, it has the first law, application of the first law, there's the second law, and applications. It has potentials, the chemical potential, the third law, kinetic theory of gases, statistical thermodynamics, classical and quantum statistics, classical statistical treatment of an ideal gas, a diatomic gas, heat capacity, magnetism, Bose-Einstein gases, Fermi-Dirac gases, and in the end, information theory. I worked through a big part of this book, and while the book is good, even though it contains some typos and some problems which I'm not sure are really solvable, I did not choose to continue with this book because I think there were better books out there, and I think it's an okay book, but there are better books out there basically on the same topic. It might be a good side resource. It might be something that the ordering of the topics is really nice, so maybe that could be interesting to you. But aside from that, I'm not sure I would really recommend this book. Next, we come to a statistics book. Here we see a book by Molenbergs and Verbeke, Models of Discrete Longitudinal Data. So it's a book on longitudinal data analysis by two of my professors at university who taught me. So it's all about generalized linear models, mixed models, marginal models, likelihood-based models, conditional models, pseudo-likelihoods, subject-specific models, nonlinear models. So a lot of things about longitudinal models. The book is really about how to do longitudinal model theory. It's not about the theory, it's not about the math, it's not about why things work, it's more about how to do it and how in practice you can fit models and basically let them work. I never really read this book, so I can't comment whether it's really good or not. Next, we come to a book by Anderson on Introduction to Multivariate Statistical Analysis, which is all about multivariate analysis, basically, like the title says. It starts with a normal distribution. It does all kinds of statistics, t-square statistics, classification of observations, sample covariance matrix, general linear hypothesis. It has independent set of variables, testing hypotheses, principal components, canonical correlations, vector analysis. So these are topics which are usually treated as machine learning, but here they're really done really rigorously. This is really a rigorous book. This is really a mathematical book, even though mathematical from statistics point of view. But it's if you're interested in the math behind this stuff and why it works and how it works and how things are proven, this is really the book that you should be looking at. It's really expansive. It's really rigorous, and there's a lot in here that you can know about. As you can tell, the math is non-negligible. Next comes a book I really like from an author I really like and that I've talked about before. It's a book by Nahin, Chases and Escapes. And basically the book is about, say that you chase somebody. Say that there's a ship there and you have another ship and you're going right towards the other ship. So the first ship moves and the chaser moves right towards it. What is the curve that you're going to have? So these are typical pursuit problems, and this is what the book is all about. It's a very niche topic, but it has some extremely beautiful math, and it has some extremely beautiful differential equations. Here we see a ship chasing another ship, and it leads to a differential equation, which is then subsequently solved. So definitely, yeah. If you want to get something useful out of this book, you won't, because this is not a useful topic. It is more like a fun topic. And yeah, I think it really is beautiful, and it shows how beautiful math can really be, and how modeling math can lead to analysis questions. Now analysis questions can lead to modeling questions, and so on. Extremely good book, very good bedtime reading book. Highly recommended, of course. Next comes a book on regression by Farmer, Knijp, Lang, and Marx. Regression, Models, Method, and Application. This is a book on how to do regression. So it has regression models, it has the classical linear model, extension of the classical linear model, generalized linear models, categorical regression, mixed models, non-parametric regression, structured additive regression, quantile regression. So it's all kinds of regressions, and basically how to do it. So again, not much math here. Mostly tells you how to do it, and what problems you can face and how to fix those problems, and how to fit the data in practice. Let's say you have a problem with fitting your data, like your variances aren't equal, what you do, how does that appear in practice, and so on. A very practical how-to-do book. Highly recommended. I really like this book. I really think it's excellent book on topics of regression. If you're looking for a mathematical book, this is not it. If you're looking for a how-to book, this is the book I would definitely recommend. Then a book on dynamic equations on timescales by Boehner and Peterson. So what's timescales? Basically, timescales are a generalization of both analysis and combinatorics, and they generalize both differential equations and difference equations. They generalize both summations and integrals. So the discrete theory and the continuous theory are basically generalized into one important framework, and that's what this book does. A very niche topic, but extremely interesting, and it can be extremely beautiful. I'm really interested in this kind of generalizations, so I was very interested in this book, and I do think the book is very much about what it promises. So yeah, if you're interested in a common setting of differential and difference equations, yeah, you want to do this book basically. It's the best book on the topic. Then finally, I have this book, Harmonic Analysis, Real Variable Methods, Orthogonality, and Oscillatory Integrals by Stein. A very comprehensive, thick book on the topic. So it has maximal functions, Hardy spaces, H1 and BMO, pseudo-differential operators, oscillatory integrals, introduction of the Heisenberg group. I tried to work through this book. I honestly found it a bit boring, maybe because I'm not into harmonic analysis and never was into harmonic analysis. I really didn't see the point of doing any of this stuff. So Mirror, if you want this book, if you want me to send you this book for free, hit me up and I will, because I'm not sure I really am ever going to read this. Alright, thanks a lot.